Welcome back, guys. Here we're going to jump into 2.2. Now, in 2.1, you talked about all different types of graphs. Why? Because we're talking about organization of our statistical data. In chapter 1, we learned about collecting data and the different features of statistical studies. In chapter 2, we're organizing our data. So you learned about all those different graph types. In 2.2, we're going to talk about a specific one, namely the histogram. The histogram is a specific type of bar graph that is very convenient and useful for portraying statistical data. So what are the features of a histogram? Well, the bars are always going to touch, okay? Unlike some bar graphs, the bars are going to touch in a histogram. In addition, you are going to be using only quantitative data. You're not going to be using any categorical or qualitative data. Nothing word-based or put into categories. It's going to be quantitative data. And then finally, your height is going to be your frequency. Your y-axis will always be a frequency, not a percentage and not a specified amount. So those are kind of the three features of the histogram you need to know. Again, I'd take a second, pause it, write it down. Not necessarily so that you can regurgitate what they are, but so you can recognize when you see a histogram. Now the question becomes, why are we learning about these? Well, because when we organize our data, it's important that we can present it in a concise manner that clearly conveys what we're trying to tell whoever we're presenting to. The example you're going to see me use here is this angry customer. The amount of time on hold an angry customer spends. So let's say I work for a telephone service company that fields calls, and we have an irate customer, and the customer calls 40 different times. And for the logs and the records, my manager would like to know how irate really is this customer? How long are they spending calling? Well, me just showing them this data could do them some good, but it's going to be better presented in a graph or a format. Anybody be sitting there going, okay, Mr. Carter, is it really that important here? Maybe, maybe not. You could make your arguments, but I can tell you this, if you plan on going into any form of the business world, it is imperative you are able to present data in a clear and concise manner in a visually appealing fashion. So a histogram may be one way to do that for our statistical data. So the question becomes, how are we going to make this histogram? What goes into it? Well, we need to decide the number of bars. When you think about the histogram, it has all those bars. We got to figure out how many we want. So to figure that out, I will provide it for you. You could see on below for the example we're going to use, we will be using 5 classes or bars. I will use those words interchangeably. Again, typically you're going to see 5 to 15. Why 5 to 15? We don't want to be less than 5 because then you're going to lose some data in translation. It's going to be too general. Whereas if you use 15, the data can become very clunky. It can be not very visually appealing for the eyes. It becomes too specific and concentrated. 5 to 15 is kind of the sweet spot where you still get the good idea of the data. You're not overgeneralizing, but you're also not bogging down your viewer. Next step, you're going to decide on how wide the classes or the bars will be. You're going to find out as we go through this, we're not going to jump straight into histogram creation. Rather, we're going to make a table and then translate that table into the graph. So how wide will the classes or the bars be when we want to make a histogram? Well, you're going to take your largest data value. I'm going to label that LDV. Again, that's largest data value, minus your SDV, or smallest data value, divided by how many classes you want, your number of classes. Again, I'd take a second. Please make sure you write down all these steps in order. It is important you know how to do these. Largest data value minus the smallest data value divided by the number of classes you have. Again, I'm going to be bouncing back and forth between the definitions and the examples. So how would I structure your notes? Well, maybe on the left side of your paper, you have definitions, and on the right side, you follow along with the example. However you want to structure it, just know I'm bouncing back and forth. So let's go down here. Again, we want to make 5 classes for our angry customer data. Well, what I need to do is I know I want 5 classes, so I need to determine my class width from there. Class width. Okay? So my class width, I'm going to find by taking my largest data value. So if I look at that here, my largest data value appears to be 13, minus my smallest data value, which appears to be 1, divided by how many classes I want, which is 5. Now, if you're jumping into a calculator already, I'm going to grab one myself, you're going to find that won't produce a whole number, right? 12 divided by 5 is going to give us 2.4. 2.4. Okay? So if our class width is 2.4, the question becomes, what do we do when we get a decimal? Okay? When you get a decimal, please always round up. Now you may be sitting there going, oh, well, it's 4, shouldn't you round down? In stats with our class width when making histograms, we always want to round up. By doing this, we will ensure that we can include all of our data within 5 classes. If I would round down based on that width, I would run out of room. I would fill my 5 classes without getting all the data. So my class width will be 3. Again, how did I get there? Largest data value minus smallest divided by the number of classes. I rounded up and I got 3. Okay, so I'm, again, pause this and write down what I have. I'm going to erase my work for saving space purposes. But our class width for our example will be 3. Okay, so let's move on to the next step. We've got our class width. Now we're going to identify our upper and lower class limits. What are the upper and lower class limits? Well, that's eventually going to create the bottoms of these bars here, these categories. So our histogram is only going to have 5 bars as opposed to the example you see here. And we just decided how wide ours were going to be. But now we need to figure out what are the specific values. So how do we identify the lower and upper class limits? Well, these are the lowest and highest values that fit into each class. Okay, so how do we find the lower class limits? Well, we're going to take our lowest data value, or our SDV, our smallest data value. Again, same thing we did up here. Our SDV, and then we are going to add the class width to it. And what that gives you is your next smallest data value. It will give you your next smallest data value, okay, or your next lower class limit. Okay, so I'm taking my smallest data value, I'm adding the class width, and it's going to give me my next smallest data value. And then I'm going to do that again, and it'll give me my next smallest data value, and the next, and the next. Now, you might be sitting there with Mr. Carter, this makes no sense. Well, follow my example here, and I think you'll get the right idea. So we have our class width here, and now I want to create my lower class limits. I want to start to create those boundaries that'll fill up the x-axis. So what am I going to do? Well, I've got a class width of 3, and my smallest data value is 1. So what I'm going to do here for my lower class limits, again, we know the class width is 3. For my lower class limits, I start with 1. Then I'm going to add the class width. And that gives me my next lower class limit. So 1 plus 3 is 4. Okay, I add that 3 again, and I get 7. Add it again, I'm going to get 10. Add it one more time, I get 13. These are going to be the lower class limits. Okay, this is my class limits. Or in other words, the stuff that's going to make up the x-axis of my bar, or my bar graph, or my histogram, the bars in my histogram. So I've got my lower class limits. Again, how did I do that? I took the smallest data value, I added the class width to it, and then I got my next lowest class limit. Then I added it 3 again, which is my class width, to get my another lower class limit, and so on and so forth. Again, you take your smallest data value, add the class width, giving you the next smallest data value, and then you repeat until you get all your lower class limits. So now how do I get my upper class limits? Well, your upper class limits are quite simple. They are going to be one value below the next lower class limit. So when I see that my class starts at 1 and the next class starts at 4, where does the previous class end? 3. If my class starts at 4 and the next one starts at 7, that means the previous one ends at 6, and so on and so forth. How do you know if you've done this right? The difference between your upper class limits, just like your lower class limits, will be 3. So what do I mean by that? I'm going up by 3 with my lower class limits. Why? Because that's the class width. You can observe the same thing with the upper class limits. I'm going up by 3. That is the class width. Okay? So now I have my class limits. This is the framework that we're going to use to create our bars on the x-axis. Again, if you want to pause the video at this point because you're confused, let me know. But basically what we did is once we had our class width, we started with the smallest data value, added the class width to it, created the lower class limits, then we looked and said, okay, well, if the next class is starting here, say at 4, where does the previous class need to end? 1 before that. Okay? So that's how we get our class limits. So where do we go from there? What's the next step? We talked about identifying the lower and upper class limits. Again, if you want the definition for the upper class limits, you can, what we did there was we looked where the next class started, and then we stopped at the one before. So create a frequency table. What's a frequency table? Well, you've heard me throw this term around before. This is what we're doing at the bottom of the page with the example. I'm creating a table of data so that I can make my histogram. What's the frequency table include? Well, it's going to be this table, and it's going to have your class limits, your class boundaries, your midpoint, your frequency. This is a frequency table, okay? Class limits, class boundaries, midpoint, frequency. What do you need to know? We use it to create the histogram. So what are class boundaries? You just heard me use that term. What in the world are the class boundaries? Well, the class boundaries, if you look at this and you go, okay, I kind of see, Mr. Carter, how we have a framework for what's going to go on the x-axis. But what you notice is the bars touch. If we look back up here, my bars are touching. 20 to 30, 30 to 40, 40 to 50. Well, what's mine look like right now? Well, it's 1 to 3, then 4 to 6, then 7 to 9. There's a gap there. So how do you find the class boundaries? You are going to add 0.5 to your upper class limits, and you are going to subtract 0.5 to your lower class limits. Again, add 0.5 to the upper class, subtract 0.5 to your lower class. So what's this look like for my frequency table that I'm making down here? Well, my class boundaries, I'm going to add 0.5 to my upper class limits, and I will subtract 0.5 from my lower class limits. When I do this by adding and subtracting the 0.5, I get bars that will now touch. And all I have done here is I've added 0.5 to my upper class limits and subtracted 0.5 from my lower class limits. This enables the bars to touch. Okay? So we have our class limits, our class boundaries. The other thing I added in here that I said we were going to find would be the midpoint. You can see it right here. How do we find the midpoint? Well, the midpoint of each class is simply you take the class limit. So how do we find the midpoint? You're going to take the class limit, or the lower class limit plus the upper class limit divided by 2. So how do I find the midpoint of the first class? 1 plus 3 is 4, divided by 2 is 2. 4 plus 6 is 10, divided by 2 is 5. 7 plus 9 is 16, divided by 2 is 8. Now a pattern you might also notice again, we are increasing by our class width. We are increasing by our class width. We always are increasing and decreasing by the class width. So 10 plus 12, 22, divided by 2, 11. 13 plus 15, 28, divided by 2, 14. Again, those are going to be your class midpoints. Midpoint should not be anything too new. Okay, and the final step for this whole deal, and this is kind of where we put all the pieces to the puzzle, is really what we've done so far is we have set up our x-axis for our histogram. What we now need to do is get the y-axis. Remember, the y-axis of the histogram is the frequency. What does the frequency stand for? How many values fit into each class. So how do I do this? Well, I simply look at my data now and I count how many pieces of data fit into each class. So my first class boundary, 0.5 to 3.5, or the class limit 1 to 3, I'm going to count all the values that fit in there. I will circle them below. So 1, 2, 3. I have 3 values, as I double check here, 3 values that fit into that first class. Now let's do the second one. The second class is 4 to 6. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, a big jump to 15 values in my second class. My third class, 7 to 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 values in my third class. My fourth class, 10 to 12, I have 1, 2, 3, 4 values. And then finally, I have 1 value in my final class, this 13 here. So what I've done is this, what you're looking at right now is a frequency table. Again, the quick summary. How do we develop the frequency table? We decide on the number of bars that'll typically be given to you. We then get the class width. We take our lowest data value, or our largest data value minus our smallest data value divided by the number of classes. We did 13 minus 1, which gave us 12 divided by 5. Again, always round up. We then identify our upper and lower class limits. We take the smallest data value. We add the class width, and that gives us our next smallest data value, which is the next lower class limit. From there, we make the frequency table. Again, we want our class limits, class boundaries, midpoint, and frequency. How do we get the class boundaries? We add 0.5 to our upper class limits, and subtract 0.5 from the lower class limits. Again, very hard to conceptualize, but I hope the example's making sense. I hope the example's making sense. If it's not, pause the video and let me know. There are a lot of steps to this, and so it's going to take a lot of practice for you to get better. So what happens now that we have our frequency? Well, now we get to make the histogram. We actually get to make the graph. So what is our graph physically going to look like? Well, remember, on the vertical axis, we're going to have our frequency, right? This is, again, in the context of the problem, what is our frequency? How many calls last per bar? Or how many calls fall between each time frame? What's on our bottom here? Well, we're going to have our class boundaries. Now what you'll notice is we're going to start at 0.5 to 3.5 to 6.5, 9.5, 12.5, 15.5. And then here we're going to go simply, we'll go up by 5. 5, 10, 15. 5, 10, 15. Okay? Again, I do want you, and we'll practice this, to be able to interpret in the context of the problem what the frequency and the class boundaries mean. For my data about the angry caller, and this is the length of time the calls last, my frequency is going to be the number of calls which fall in each time frame. So now, the final step to making my histogram, I simply create the bars. So for class 1, my frequency was 3. So I'm going to make a bar up to about 3. Then for 3.5, I had 15 calls. So my second class is going to go all the way up to 15. My third class had 17. Third class had 17. It's going to be even higher. Then we drop back down, right? My fourth class only had 4, and my last class has 1. So I've got 4, and I've got 1. Okay, and this is how we make a histogram. Again, the title I could put here, length of call time by angry customer. My class boundary, or my frequency, number of calls, class boundary, length of time. And when you look at this graph, though it is hand-drawn, it is much more effective than looking at all those numbers. I can look at this and very clearly see that the majority of the calls made by this angry customer lasted between 3.5 minutes and 9.5 minutes. Again, these are huge. Now you might be sitting there going, oh my gosh, it's so many steps. I promise we'll practice it a lot and you'll get better. But please, if you did not take good notes to this point, go back and really follow with the example and take good notes. Okay, couple more pieces to this whole thing. Relative frequency. This is an optional category that we may or may not add on to our frequency tables. So remember, your typical frequency table has your class limits, then your class boundaries, your midpoint, your frequency, and then your relative frequency. Relative frequency is just going to be a percentage. You are going to take the frequency and divide by however many there are. So remember, I went 3, 15, 17, 4, 1, I believe, for my data. 3, 15, 17, 4, 1, where my frequency's above. What would the relative frequency be? Well, if I add all this up, if I do 3 plus 15 plus 17 plus 4 plus 1, I get a grand total of 40. There were 40 calls made. So then I simply just take my frequency and divide it by the total number of calls made. When you do this, you get 0.075 or 7.5%. 15 divided by 40 would be 37.5%. Again, in decimal form, that's 0.375. This would be 0.075. And so on and so forth. Again, just an optional way of conveying the data if we wanted to put it as percentages as opposed to just frequencies. So if you ever hear of a relative frequency histogram, on the y-axis, instead of just the frequency numbers, you'll have percentages that come from the relative frequency. Again, pretty self-explanatory. If you are asked in your homework, and I believe you are, to create a relative frequency table or a relative frequency histogram, just add that extra column onto your frequency table. And all you need to do is add up all your frequencies, and then for each class, divide your frequency by the total number of frequencies. Okay, final steps. So once we've created all of our histograms, there are several shapes that will become present and will be common. There will be the symmetrical shape. This is a very common one. It's actually referred to as often the normal curve, and we'll get into that later in stats. You also could see uniform distributions. What will the uniform distributions look like? This would be a graph. The uniform would have the same frequency. So it would be if my histogram looked like this. That is the uniform distribution. Everything looks the same. Bimodal, if you look at that prefix, you might think of bicycle, 2 wheels. A bimodal distribution will have 2 peaks. So it might look something like this. A bimodal distribution, okay? And we'll have 2 peaks. They're separated by at least 1 class. That's the difference between a symmetrical, which looks something like this, and a bimodal. A bimodal, that peak is separated by a class. That is a bimodal. And then finally, you have skewed left or skewed right. What are we looking at for skewed left or skewed right? Well, skewed left or skewed right will have tails. So they'll kind of be increasing in nature, and one end will be higher than the other. And again, skewed left or skewed right. You kind of have a couple options. Now, how can you tell which is skewed left and skewed right? Well, skewed left, the peak is on the, you can think opposite. Skewed left, the peak's going to be on the right side. Skewed right, the peak will be on the left side. Okay, so these are the different distribution shapes you can see or will commonly see with histograms. Okay, so I know we're walking away with a lot. What's the summary? Please take good notes on how to make histograms. We're going to spend time making them. It's a great way to organize our data. Once we make the histogram, we make the frequency table. And again, all the steps for that are listed above. And then once we make histograms, as we analyze histograms, these are the different shapes we'll see. Thanks for listening. Let me know if you have any questions.